Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 13. This is Section 15.2. It's problem number 13. We want to find the integral of x squared e to the 5x cubed plus 1 dx. So this is something you really need the substitution method for. To do the substitution method, the first thing I'm going to do is choose a value for u. There's really only one thing that fits for u, which is the power of e. So my typical choices are stuff in parentheses. This problem has no parentheses. Stuff under the root, there is no root. Stuff in the denominator, there is no denominator. It has to be the power of e. So the value of u must be 5x cubed plus 1. There's nothing else that fits. So the next thing you do is find du, the derivative of u. So the 5x cubed has a derivative of 15x squared. And that's coming from the exponent of 3 coming down times the number in front, which is 5. 3 times 5, this is my 15. X to one less power, the third power drops down to a second power. The plus 1 on the end, it has no x, so its derivative is just 0. It's 15x squared plus 0, which is 15x squared. But at the end, you put dx for derivative with respect to x. So the next thing I'm going to do is rewrite this original integral in terms of my new variable u instead of the x that I got it with. Now when I do that, the x squared that's in front of the e to some power, I would rather have the x squared over with the dx that's on the far right. And I can do that because it's really x squared times e to that power. I can pull the x squared over and put it with the dx if I want to. Because you can multiply things in any order and get the same answer. So let me write it as e to the 5x cubed plus 1 times x squared dx. And that's going to make the substitution with my new variable a little more clear. So as I rewrite it, the e to the 5x cubed plus 1 is a very easy match for e to the u. Now, I've got the e to some power part matched up nicely. X squared dx, I don't quite have a perfect match for. I have an x squared dx, but there's a times 15 in front of it. I have to cancel the 15. Again, this trick has come up a few times. I have an equation. I can do whatever I want as long as I do the same thing on both sides. So on both sides, I'm going to do times 1 over 15. 1 over 15 times the left side of my equal sign, and 1 over 15 times the right side of my equal sign. On the left, 1/15 times du gives me 1/15 du. And on the right, 1/15 times 15x squared dx, the 15s will cancel. So I have 1/15 du equals x squared dx. I need to replace x squared dx, and now I have a perfect match for what it's equal to. It's equal to 1/15 du. And again, that fraction of 1/15 can sit where it is in the middle of my integral, which makes it look pretty weird. But because there's no variable with it, I do have the right to pull it in front of the integral symbol, which I would much rather do. It makes it look much more normal. So I'm going to have 1/15 times the integral of e to the u du, which is a pretty easy integral to solve. E to the u is the easiest integral there is, just e to the u. Now the 1/15 that's in front will stay in front. E to the u, when I do the integral, the du and the integral symbol disappear together. And I have to remember this plus some constant. To finish the problem to the end, I can't leave the answer in terms of the new variable that I substituted in. I have to put it back to the original variable, which in this problem is x. So my final answer would be 1/15 e to the 5x cubed plus 1 exponent, and then plus a constant.